Oh, hello, geometry class. I'm just sitting here listening to your playlist. And if you notice, it's Don't Stop Me Now by Queen, which means that we're not going to stop. Let's keep going. We're going to start now with Chapter 11. We're going to learn some more about circles. This is a warm-up. We're not going to go through everything. What I just really want to touch upon is the fact that if you notice these fractions are comparing degree measures with circles, okay, you'll learn probably algebra 2 that you can do it with degrees or radians, which would be in pi. And when we want to simplify, we can simplify this fraction like 120 over 360 would be, let me hit my pen. Right, 120 over 360, well that's right 1/3 of 9 pi. And if I simplified it and I want it in exact, it would be right 3 pi. Okay, so we're going to be doing this today. We're going to be writing proportions that involve the degree length. We're going to be comparing with circumference, and we're going to have to cross multiply. And we're going to create proportions. To review, the circumference of a circle is pi times diameter, or if you're given the radius, double the radius and multiply it by pi. So it depends on what you're given. Okay, so a bicycle wheel is a great example of a circle, and it has a diameter of 24 inches. Find the circumference in terms of pi. And you remember, to be exact, it would be in terms of pi. So pi times diameter, 24 pi. And that's your answer. Find the circumference to the nearest tenth of an inch. Well, on this one, you're going to want to put it into your calculator. So 24 times pi, I got 75.4. Your answers might vary slightly depending on whether or not you use the pi button or 3.14. How far will the bike travel if the wheel makes one revolution? Well, that's one rotation of the circumference, 70.4 inches. How far will the bike travel if the wheel makes 100 revolutions? Well, multiply it by 100. There you go. How many revolutions will the wheel make in 1 mile? Oh, and I got to remember how many inches. Oh, let's start with feet. How many feet in a mile? 5 tomatoes, 5280 feet. That's how many in 1 mile. All right, and then I want to convert it. I'm going to put my feet in the bottom so that these cancel out in 12 inches. Multiply across. You get 63,360. That's how many inches it'll travel. But the question was, how many revolutions? Well, if it's 75.4 inches in one revolution, let's divide by 75.4. And let's see what we get. I didn't do this out yet. I got 840, we'll round to the nearest hundredth, 0.32. And that's how many revolutions. There we go. Okay, so now we reviewed circumference. All right, so I put the blank notes in Classroom. You can add to these. In Chapter 10, we discussed the measure of the arc AB, and now we want to determine the length. So when we measured the arc, so I made some notes down here. When we say the measure of arc AB, that means it wants it in degrees. Now, if you want the length of AB, it's going to be a measure such as feet, inches, etc. It would be like if we unrolled. So I'll put this post in Classroom again. You'll see that it's actually related. So if you think of this arc AB, that's a piece of the circumference. So we're going to compare that piece of the circumference to the whole circumference to find whatever length we're looking for. So the arc length corollary says that in a circle, the ratio of the length of a given arc to the circumference, so think piece to the whole, equals the ratio of the measure of the arc in degrees to 360 degrees. So again, think of it this way. The arc length of AB, that piece, and I wrote 2 pi r here. You could just write circumference because it depends on if you're given the radius or diameter. So the piece to the whole of circumference equals, it forms a ratio with the measure of the angle degrees of AB to 360 because 360 is the whole circle. Another way of thinking of it is if I'm just looking for this arc length AB, I'm doing the measure of arc AB over 360 times the circumference. And so in this case, it was 2 pi r or pi d. Let me take a minute to write that in your notes. Okay, so let's go back to circumference. All right, and it says round 1 through 3 to the nearest hundredth, but I cut out some of the examples in the interest of time. So if I want to find the circumference, well, circumference is 2 times pi times 5.7. We're given the radius halfway across. Right? So when I do out that math, I get 35.81 centimeters. Okay, just plug it into the formula. Okay, here I'm given the circumference. So if the circumference is 94, the 94, right, wants the radius, 2 pi r. We could still do diameter. Divide by 2, 47 equal. Actually, in one step, I could have done divide by 2 and pi. So if I did that, either way, you get the radius is 14.96 inches. Now here, the exact radius of a circle, the circumference is 74. Right, so that means it wants it in terms of pi. So if 74 equals 2 pi r, let's divide both sides by 2 pi. I'm just going to leave the pi like it is, so I can just do 74 divided by 2. So your radius is 37 pi centimeters. Just like that. Okay, well now let's actually apply the proportion that we just learned. So if I want to find the length of AB, and I'm given here that 14.2 is the radius, and I'm given the arc measure of AB. So I like to use the ratio. You can use where I said length of AB equals the degrees times circumference, however you like. But I'm going to set it up like this. Length of AB over 2 times pi, the radius is 14.2, equals, well, the piece, the degree measures was 145 over the whole 360. All right, so you cross multiply. Right? So if I call this x, so I multiply these two and then divide by 360, and I get 35.94 inches. All right, if you want to pause here and answer these on your own, you can. I'll be going through each answer. All right, so when I read this problem, ADC is congruent to BDC. Right? So if these are congruent, and I know that's 101, that helps me find. So if I'm looking for our arc ACB, that's going to be 360 minus 101. That's 259 degrees. Well, CB is half of that because they're congruent, 129.5. All right, ACB. And this is where I'm going to start my proportion. So I'm going to start over here. So for 9, the proportion I'm going to solve, I'm looking for the length of ACB. So that's my x over my circumference. All right, so 2 pi 24.9 equals, well, what was the degree measure of that one? We said that was 259 over 360. So we're going to cross multiply, solve for x, and you should get 112.56 meters. For 10, we want to find the measure of the length of CB. Right? So again, I'm going to use the proportion. So again, x over 2 pi 24.9 equals, what was the degree measure of that? 129.5. So the only difference between 9 and 10 is at the top, the degree measure changes. All right, so cross multiply, and you should get 56.28, right? It's also half of this, right? Which we also knew we could have taken half of that to begin with. Measure of arc ABC, well, that's going to be, this is looking for degrees, so it's 101 plus 129.5. So just add those two degrees together, you get 230.5. 12, the length of arc BAC. All right, so I'm going to use the degrees I just found. So this is for 12. All right, so the radius hasn't changed. It's the same circle. All right, and I'm going to set that in proportion with 230.5 over 360. So again, it's just changing the degree measure because we're looking at a different piece of that circle. All right, and when I do that out, you should get about 100.17 meters. All right, so yeah, remember, piece to the whole, piece to the whole. All right, this one's a little bit different. So I'm going to find the circumference of circle Q. So I know that my ratio here, so I have it's giving me my arc length of AB, so 12, and it's asking me for the circumference. So I'm just going to put C down there because that really was what the formula was. Right, equals, it tells me the arc length 85, right, because that's the central angle, 85 over 360. Okay, so cross multiply, it's only asking for the circumference. So once you cross multiply, so 12 times 360 divided by 85, you should get 50.82 centimeters. Right, if it wanted the radius, I would divide by 2 pi, and that's how I would get my radius. Okay, last example for the day, because I want you to have time to practice. So find the perimeter of the region. All right, well, I see it's a rectangle with like quarter circles here, but they're congruent. So it's really one circle in the middle there. So I'm going to start here. If this is 6 inches, then that means this is 2, and that's 2. Right? If this is 6 inches, this is 6. Right? Now, I see that it's a circle, and I want to find, right, if this is 1/4 of the circumference, if I find the circumference of the whole thing, I'll be just fine. Okay, so the circumference, so 2 is my radius, right? So 2 pi times 2 is going to be 4 pi, right? And that'd be each piece. So that's the 4 together. Now the perimeter of the rest, so I'm going to do 6 plus 6 plus 2 plus 2, right? These and those. Whoops, that does not look like a very good 2. Right. And I get 16, right? And I'm going to leave my answer like this because it's exact and I like it. Right? So that's the perimeter of that region. Use the rest of this time to practice. Right? And I'll see you tomorrow where we learn about area, and who knows what I'll be listening to then. Have a great day.